Welcome everyone. In this video we're going to go over a 12.3 problem that's shown up on a previous exam. So in this case we're going to go over problem number 9 here from fall semester 2017. This is a tricky problem. I wouldn't say not super tricky, but it's a more conceptual problem, right? You really have to understand what is the projection of A onto B in order to get this problem correct. And that's because, right, the vectors A and B aren't given to us. I mean, we kind of have a general sense of directions and stuff like this, of maybe where they're headed, but we don't have what their actual coordinates are, right? We just kind of see B is headed this way, A is headed this way, and we want to know which of the following could be the projection of A onto B. Okay, and so if we remember the projection of A onto B, kind of we draw the line that contains the vector B here. So something, oops. Computer kind of went crazy on me. So we draw this line right here, and we want to project A onto this line that contains B, right? So if we kind of project this down at a nice 90-degree angle, we can see that, maybe I'll use purple or so. This right here is going to be the projection of A onto B. And just as kind of a nice review as well, right, this bit right here, this was also something that we had defined. This was the orthogonal projection, orth, of A onto B. And when you take these and you sum them together, you get A. So here's the orthogonal projection. Here is just the regular vector projection of A onto B. And so we can see that the projection of A onto B, right, it seems to be heading to the left and down. So the fact that it's heading to the left means that its x-coordinate must be negative, and the fact that it's heading down means that its y-coordinate must be negative. And so we go over here and we're looking for one that has a negative x-coordinate, aka heading to the left, and a negative y-coordinate, aka heading down. And so when I look, the only one that satisfies that is C. And kind of this looks reasonable, right? So -2 over -1 down. So if your coordinates were something like this, yeah, -2, -1, this seems reasonable. So again, this is a nice problem because, right, there's not a lot of math to fumble on or anything like this. You can't really make an arithmetic error, but you do really have to understand what is a vector projection. All right, that's it for this video. I'll see you guys next time.